Hey everyone, here's a really cool amplifier I just got in. This is a Sony TA-5650. This is an integrated amp from Sony from around 1975 through 1978. And what's so special about it is it uses Sony's VFETs for the outputs. Now this came to me for a full restoration, so I'm going to be doing everything to this, including cosmetic work and a rework of all the internals. So I'm going to bring you guys through the process, show you guys basically what I do, and hopefully we can get this thing working by the end. So here it is with the top panel removed, and as you can see, it's really dusty. There's a thick layer of dust on basically everything in here that needs to be cleaned off before I work on it. That way I'm able to inspect all the circuit boards and connectors and components without having dust obscure my view. So I'm going to do that before I begin work on this, and I'll bring you guys another video after I do that. Here it is after I just took it to the compressor and blew it out with air and used a paintbrush on it. You can see all the dust is gone. It looks pretty new, so it's going to be a lot easier to disassemble it and inspect it for any issues now that all the dust is gone. So I'm going to start by measuring all the VFETs, and after I do that, I'm going to verify I have proper power supply rails and my gate voltage is there. So I'll come back after I do all that. So I removed all the VFETs and tested all of them, and they all measure well. So those are all good. And I measured the gate voltage on each one of them after I removed them, and I have proper gate voltage, and my power supply rails are spot on. I also remounted all the VFETs on new sill pads. Got rid of the old mica and grease that was all dried up. This VFET right here, you can still kind of see the silk screening on it if you look at it just right, but that rubbed off. I'm not sure why. All these other ones are fine, but this one rubbed off. I was just using a microfiber cloth and some water just to get all the dust and dirt off of them, but it's not a big deal. You can still kind of read it if you look at it just right in the light. Not sure if you can see it over video, but it sucks that it happened, but you know, these things happen, so it is what it is. But for now, I have proper voltage everywhere, so I'm going to begin the restoration now that I know the amp is working properly. Starting the power supply, I have the filter caps removed from the amp. These came out as one assembly, as they're screwed to each other, and then this bracket gets screwed to the chassis. These are at 50 volt at 10,000 microfarad, and as you can see, I have them hooked up to my Sencor LC102, and they're down on capacitance quite a bit. They should be 10, and they're hovering right around 6. The capacitor leakage is pretty good. And the capacitor ESR is also good. So, because they're down on C, I'm going to have to change them either way. And I have these in stock. These are Nippon Chemicon, really high quality caps. These are 80 volts at 15,000 mic. So we're going up in voltage and capacitance, but we still should be okay doing that. These old caps are screw terminal style, and they get bolted to the chassis, excuse me, and this board sits on top of them and gets screwed to them, and that's how this board picks up electrical connection to them. But because these new style caps are not screw mount, I'm gonna have to solder some legs to them and modify them. But they're the right size. They're a little bit shorter, but that should be okay. So I'll see how it is getting these in and installed, and I'll come back with another video when I do that. Okay, I'm back with the 5650. I have the two new filter caps installed. I have them soldered into place. Came out pretty well. What I did was I soldered some wires to the tabs, and then I soldered those wires directly to the screw terminals that used to be used with these caps. So it came out pretty well. I'm gonna get started on all the front circuit boards before I move further back. So I'm gonna get things like the regulated power supply, phono stage, EQ stage. I'm gonna get that all rebuilt. So I'm gonna start by pulling all the knobs and switches off of the faceplate. And most of these knobs just pull off by hand. They're solid metal, and how they're held on is these potentiometers are split, and the spring tension between these two pieces holds these on. You can see the cutout in there, how it's grooved. Things like the volume knob are set screwed. So you have to take a screwdriver and you have to remove the set screw, and then it just pulls right off like that. And things like this is your preset volume control. So what this is you set this to where you want it, and basically when you turn the volume knob, it'll detent where you put this notch. And I have this snap-on kit right here, and these are perfect for situations like this where knobs and switches that are stuck on over the years are hard to get off. So what you do is you just come in here and you just pry it off a little bit. You got to use 2 of them. The kit comes with 3, so these come in handy really well. They don't mar your faceplate, and they don't damage anything, so those are great to have. So I'm going to keep going on this, and I'll bring you guys another video when I get further. So Sony actually made this amplifier really easy to work on, which is a surprise. The front faceplate is hinged to the front chassis, so all you have to do is remove 4 screws and loosen 2 hinge screws, and the faceplate drops down, and it makes it very easy to access all the circuit boards that are mounted to it. And there's a lot of connectors, which makes service really easy. So I'm going to go through each one of these boards and I'll give you an update as I go. So here's the front power supply board that I just took out. I'm going to give it a full recap. I'm going to reflow it, deflux it, and make sure everything else is within spec. Instead of unwrapping all these wire wraps, I just decided to unsolder this from the board. Made it a lot easier. So here's the main power supply board, all rebuilt. All new high quality capacitors, and I reflowed and defluxed the board. So this is ready to go back in. Here are the old caps that came off of it. So I'm going to stick this in, verify operation, and then I'm going to move on. Okay, so I have the power supply reinstalled and all wired up. And I've since moved over to this board. This is your volume control, muting, source selection, as well as your line stage and your phono stage. And this phono stage is cool because it uses these relatively unknown VFETs. These are 2SK79. And these are the only area in this amp that other VFETs are used, other than the output stage. So I'm going to rebuild this board just as I did with all the others. Recap it, check component values, make sure everything's in spec, and I'm also going to reflow and deflux it. So this is just a view of the board before I do that. Got some cracked solder joints on this as well. So here's the circuit board ready to be reinstalled. I completely recapped it. I measured a bunch of the component values, made sure everything was within spec. I serviced the controls and switches, and I also reflowed and I defluxed it as well. It looks pretty good. I've been getting some comments on my process for reflowing and defluxing. What I do is I coat the board in flux. I have a liquid flux, and I reflow every single joint using new solder. And then what I do is I soak it in alcohol and I scrub the flux off of it, and it comes out looking pretty good. So anyway, I'll get this reinstalled and I'll move on to the next set of boards in here. Okay, I'm just about to finish up the front here. I'm about to get the last board installed. This is the main switching board on the front. A lot of controls on it. So I serviced all those switches, I recapped it. I also reflowed and defluxed the back, per usual. And I'm about to get it reinstalled into the front. I have all the boards on the front are all set, they're ready to go. And after that, I'm going to move on to the amplifier section, which should be one of the most comprehensive jobs of this amplifier. There's some mods I'm going to do, and some service bulletin items that I have to follow as well. And then this amp should be good to go. Okay, I have the front boards reinstalled, and I ran through everything and I tested all the functions, and everything seems to be good. So now I'm going to move on to the power amp module. I'm going to pull this out as one assembly. This board is held to the heatsink via the outputs. It kind of makes a sandwich, and then this heatsink is then screwed to the chassis. What I have to do is I'm going to unsolder all these wire wrap terminals. If I undo every single solder joint, this one plastic piece comes off, and I'm going to do that for both of them. That makes it a lot easier. And then it's just this one connector, and then it'll come out, and then I can work on it from there. There's lots of stuff to do. Some service bulletins, as well as taking these VD1212s out of place. These things are notoriously bad. You got to change those out for 4148s in series. So I'll show that when I get to it. So here's the amplifier board. It comes out with the heatsink. All you have to do is remove these two connectors here, just unsolder them from the board, and then pull this one connector off for the signal. One screw in each corner of the heatsink, and this whole module comes right out. So to take this board off of the heatsink, you just take all the VFETs off and then remove these 4 brackets, and it'll pull right off for you to work on. Now this is a later generation module. This is toward the end of production. So the service bulletin that covers these amplifiers, they want you to change a bunch of component values, mainly resistors and a couple capacitors. This board has had that done from the factory, so that there doesn't need anything changed on it. So I am going to recap it and change these double diode packages out. There's 4 of them. And I'm also going to change the bias pots out. And I might change a couple of the fusible resistors as well, because those like to drift. And I'm also going to reflow and deflux the back. You can see this thing's pretty bad. Pretty nasty. Lots of dry and cracked joints and a lot of flux. I generally don't like leaving flux on boards, especially in high impedance circuits, as the flux itself can actually cause issues such as oscillation and other problems as well. So I will update you guys when I get further along. Okay, so I have the board removed from the heatsink, as well as the VFETs. And here's the new parts that are going to be put onto the board. New trimmers, resistors, diodes, and of course the capacitors. So I'm going to start one by one, changing out all these components, and then get this remounted. Here's all the VFETs. I'm also going to wash the heatsink off. It's pretty dirty. So I'll wash that, and then I'll remount the VFETs on new sill pads, and then we'll go from there. Here's the completed module. I just spent the past few hours working on this thing. Went through it with a fine-tooth comb. I changed out every single electrolytic capacitor with high-quality Nichicon and Panasonic parts. I had 6 resistors toward the back that were out of spec, so I replaced those ones with high-quality films, metal films. I have new Bourne's trimmers for the bias on each side. I also replaced the VD double diode packages with 1N4148s in series. And the ones on the outside ends, they're coupled to the transistor that sits just adjacent to them. So I have thermal compound and heat shrink tubing on them, so they'll track to those transistors properly. So other than that, I did the basic reflow and rework on the back, and that came out pretty well. Nice and shiny. How it should have been from the factory. This thing was messy. So good as new, better than new actually. I had some questions about the probes that I use also. These are SMG50s by Tektronix. These things are great. I have a little wire loom made up for them. And these things are superb for doing component level troubleshooting and work. And you can just get these right on, just like that. And they're secure. You can literally pick up a circuit board with these. They will not let go. These are about $2 each on eBay. There's a seller that has a bunch of them. I bought a whole bunch of them. So they're great for work like this. I'm moving on to the heatsink now. I have a modification that I want to do to this thing. This is the bottom side where the transistors get mounted, and these holes in the middle are where the pins in the transistor go through. You can see just how sharp the edges on these holes are. They're razor sharp. And when I use sill pads on here, I'm afraid that the sill pads are going to be cut by this jagged edge on each one of these holes. So I'm actually going to deburr each one of these holes with an angle bit. That way I won't run the risk of damaging sill pads and possibly shorting the amplifier out. I'm also going to wash this as well. It's pretty dirty. So stay tuned and I will come back when I do that. Here's the overhauled module installed back onto the heatsink. I got the heatsink all cleaned up as well as the brackets, so it looks basically brand new. And I have the holes on the bottom side deburred, so that way they won't cut into the sill pads. Nice and smooth. I'm gonna leave the VFETs out for now. I'm gonna throw this back in the amp, hook it back up, and then make sure I have all my voltages. And then from there, we'll install the VFETs and get the bias set. Okay, I'm back with a TA-5650. I've spent the past few days trying to troubleshoot this amplifier on and off. I've had this board in and out a few times, trying to solve some issues that I've been having relating to the offset and the bias. I'll start off with the offset issue that I was having. When I got this amplifier module back installed with the VFETs, I had an offset issue on the right channel of about 200 millivolts, which is not good. These amplifiers are not adjustable in terms of offset, so you have to rely on the matching of the input differentials. These two transistors on each side form your differential pair, and the gain matching characteristics of those transistors is important. It plays a key role in your DC balance of your circuit. And from the factory, they use gain match transistors, but over time the gain drifts on these with age and temperature, stress, and other factors as well. So I've had to change the transistors on the right channel out. Following that, I also changed the left, but to narrow the issue down that I was having, I swapped these out, and that solved my issue. I now have close to 0 millivolts on this channel, and after swapping these out, I also have 0 millivolts on this channel. I did have to gain match the transistors. I swapped them out for KSA 992. They're pretty much identical spec-wise to the originals, so there's not going to be an issue there. Now, with the bias issue, there was actually nothing wrong with the circuit. It was actually how Sony has you measure the bias, and I'll get to that in a second. But during my troubleshooting, I replaced all these diodes. These are 1S, I think these are 1S 2001s or 5001s. I've seen these diodes go bad, and there's a few of them around the circuit. So I have those swapped out with identical replacements, new stock. So that obviously didn't solve the issue because there was no issue. I also went around and I was verifying that all of my resistors were correct. I even referenced the service bulletin again, and I made sure that these resistors were in fact correct for the second time, just to make sure I didn't miss any. But those are all correct. All my transistors are good. The issue was the fact that Sony has you measure the bias via these two posts right here. You have one for one channel, and you have one for the other. What they have you do is measure from this post to the positive speaker terminal of each channel, and you measure the differential between those two. And from the factory, they wanted 90 millivolts between them. But the service bulletin that they came out with after had you lower it to 50. For reasons unknown, they probably thought that the amplifier was biased too hard, which was killing the VFETs. It was probably putting too much stress on the power supply, which was killing the capacitors, thus lowering the gate voltage, which in turn increases bias, and over time that will actually send the amplifier into thermal runaway. So anyway, they have you measure the bias from these posts to the speaker terminals. Now, what's in between the speaker terminals and the output of the board, the speaker output of the board? Well, you have a lot. You have all of this. You have your speaker output relay, and you have your selector switch. Now, one channel was fine measuring how they want you to. Totally fine. The other channel was fine until the amplifier got to a certain point. Now, that point, I don't know if it was temperature. It must have been temperature. I don't know if it was time the amplifier was on. But anyway, there was a bad connection, and that was causing the reading on the meter to go crazy. It would drift all over the place. And I found after hours and hours of trying to troubleshoot the circuit that was my issue. It was a bad connection down here. The speaker selector switch is what I think the issue is. So I came to that realization, and I decided to probe the actual output of the amplifier before it goes through all that mess. And indeed, my bias was about as stable as it can get. So after I found that issue out, it was kind of a major relief, because I don't have any issue with the circuit. It's all after the speaker output, before it goes to here. So figured that issue out. All new components, so at least the components in the circuit are new. You won't have to worry about age and thermal stress of them for another great period of time. But now that that's done, I can finally reinstall this board into the amplifier and get on with the restoration. I wanted to be done with this a couple days ago, and it just didn't go according to plan. So I'm gonna get this amplifier module reinstalled, and I'll give you guys an update when I get back. But yeah, if you guys are doing this, so just really reading into these amplifiers, they're pretty tricky to get right, and because the VFETs are not sourceable anymore, they don't make them. If you mess up, then you're screwed. So I've been trying to be very, very careful with this amplifier. I always test the amplifier without the VFETs in it first. Make sure my gate voltage is there. Make sure there's no abnormalities. So if you guys are doing this, just make sure that the connection down here for the speaker terminal where you measure is correct. If you want to bypass all that and you want to make sure that you don't have an issue, the board is actually labeled where you have to measure. You can see here, here's your two positive rails and your negative rails, and right here you have out left and out right. Well, on this side, this is your left channel, and out right is not connected to anything. So there's a post there, but it's not connected. So you're gonna measure right here. This is your speaker output, right as it comes out of the amplifier. So that's your left. You come over here, out, this is your right. So you wanna make sure your bias is solid and you're not sure if it's caused by all the mess in here. Measure it here. Measure from this post to out, and this post to out. That's all you gotta do. So I'll come back with another update soon. Okay, I have the amplifier module back in, and before installing the VFETs, I verified gate voltage and power supply voltage. I installed the VFETs and turned the amp on. Now it's warming up, and it's almost up to temp. We're sitting right around 50 millivolts on each channel, which is right where it needs to be for bias. And I'm measuring right at the spots that I was talking about. If I swap over from the bias test point to ground, it'll give me my offset. And because positive is going to ground, in this case, the right channel sitting at 5 millivolts and the left channel sitting right at about 3. So that's pretty good, considering there's no offset adjustment. It's all done by gain matching. So in the manual they want it plus minus 50 millivolts. So 5 millivolts is pretty good. So I'm gonna let this thing warm up further, make sure it's solid, and we'll go from there. Here's the speaker selector switch out of the Sony. As you can see, the contacts are pretty dirty. I'm not sure how clean I'm gonna be able to get this, but it'll be better than just spraying deoxidin. I do not want to disassemble this thing. There are some people that do that, but I do not feel comfortable with something as delicate as this. This is the board it came off of. The relay I already opened up. I inspected the contacts. They're basically brand new, so that relay is fine. So for now, I'm gonna focus on the speaker selector switch. Come back when I'm done. Here's the speaker selector switch after cleaning. I think you'll agree it looks a lot better. Nice and clean now. I used some solvent and an acid brush. I cleaned the contacts. Got a lot of dirt out, oxidation. So I'm gonna reinstall this. I actually have to solder in a new post. The post broke off during removal, and it was bent over from the factory, so when bending it back, it fell off. So I'm gonna solder on a new post and then reinstall this. We'll go on from there. So I have the speaker selector switch reinstalled, and I have it mounted back to the front subplate. And I wanted to show the mod that I did to the power supply. I forgot to mention this. This is the voltage doubler right here, these two diodes that are in series. And what I did was I added another diode in series, and I tied the center of the two to ground. And when that does, is it stops the voltage from fluctuating due to uneven loading on the supply. This is a well-known mod online, and it works really well. The rail voltages are now rock solid versus before when they used to drift plus or minus a few volts. So that's another mod that I can attest to that works really well. So I'm going to get the front plate reassembled. I'm going to get it bolted back up, and I'm going to turn my attention to the faceplate. Here's a quick look at the faceplate before I clean and polish it. It's pretty dirty, lots of stains and grime on it. I'll make it look like new, except for that one little nick. And same with the knobs. I'll come back when I'm done with that. Okay, I got the faceplate installed with all the knobs and switches. And it looks basically brand new. It was pretty hard to clean all these knobs because they're textured, but I managed to get in there and give them a pretty deep clean, and they look brand new. I even polished all the 1/4-inch jacks on the front. I'm gonna move to the rear panel now. I got some stuff to do on the back, namely the RCA jacks. Got to polish those up. I'm actually gonna pull the assemblies out and do it that way. And one of the last things to do is to remove this lamp cord and put an IEC jack on it. So I'll come back when I'm in the process of doing that. Okay, so I have the rear panel removed, and I have a bunch of the jacks polished up already. You can see how shiny they are. I also have the ground terminal polished up. I reworked the circuit board back here, and I have these jacks removed just to illustrate what they look like. They're pretty oxidized and just nasty. It takes a lot of force to put the plugs in and take the plugs back out. So when I polish these up, that'll be a lot easier. I also polished the internal contact as well. After I do that, I'm gonna change these spring clips out for proper 5-way binding posts. I'm gonna make an adapter plate and seat them where these old spring clips are. They'll fit right into place. And the last step is to put an IC inlet on the back. So it completely modernizes the rear I/O of this amplifier. Makes it a lot easier to use with new equipment and new speakers as well. So I'll come back when I finish all that up. So after a few days of waiting, I finally got the posts in, as well as the IC inlet. Just got those installed. Looks pretty good. Came out well. I had to make a little plate for the binding post to mount to. And I chopped out the back panel a little bit to make the IC inlet fit. I also added some cork underneath these chimneys because before I did that, these would rattle. So I threw that under there. It puts a preload on these so they don't rattle anymore. All that holds these in are these little tabs that bend. It's kind of a shitty design, but it is what it is. What else? I polished the shorting plugs for the phono stage and for the pre-power jumpers as well. I also got my sticker on there. So I'm going to throw the top cover on after I bolt this panel back in and get the wood sides on, and then I'll throw it on the measurement rig, see how it does. Got the side panels on as well as the top cover. This thing's pristine. You can see my reflection in the faceplate. That's how clean it is. This thing is just superb. So I have it hooked up to my distortion analyzer and into an 8 ohm load, full power, 60 watts. It's outputting 0.01% THD, which is superb. Just over 22 volts, which is right around 60 watts. Clean sine wave. Perfect. So I'm going to verify some other measurements and then get it hooked up to my system, see how it sounds. Okay, I got it hooked up, and it sounds as good as it looks. In this light, you can see the faceplate, how it cleaned up. polished up well. And the case is also superb. There's not a scratch on it. And the rear I/O came out well too. But yeah, this thing sounds as good as it looks and performs. Sounds a lot like tubes, really smooth and detailed. Overall, I'm really happy with how this turned out. Couldn't really ask for a better end product, so the owner is going to be really happy, and that's what I care about. And it also makes for a great video for YouTube too. I know there's a lot of people that are anxiously waiting for this, so I'm gonna get this edited and uploaded, and should have it out by tomorrow. And just as a sneak peek, this is the next product I'm working on. It's a Kenwood L07C2. And for a full restoration, just like the 07M2s, for the same owner. So keep an eye out for that. But for now, thanks for watching.